Hi everyone. So today's question is going to be a long jumper who leaves the ground with an initial velocity of 12 meters per second at an angle of 28 degrees above the horizontal. First thing we can do is draw that takeoff. 12 meters per second, 28 degrees above the horizontal. So it's looking for determine the time of flight. So our t is a question mark, our horizontal distance, and our peak height of the jumper. So these are the three, items we're looking for. So let's complete this triangle here, make it a right angle triangle. And here we will know our y velocity at takeoff and our x velocity at takeoff. So this triangle here is all for the takeoff velocity. It's not representative of the entire jump. The whole actual jump will look something like this, with a takeoff of 28 degrees and a landing of 28 degrees. So if you all remember your SOHCAHTOA, we have our sine is opposite over adjacent and our cosine is adjacent over hypotenuse. Tan we won't worry about for this triangle here. So we know that sine 28 is equal to our y velocity over 12, and the same thing for our cosine equals x velocity over 12. So we rearrange for both the y vel and the x vel, and this gives us 5.63 meters per second at takeoff, and our x velocity, which actually does not change throughout the duration of the jump, is 10.6 meters per second. The y velocity, of course, will change during the jump due to gravity, so we will take off at 5.63 and actually land at 5.63 as well, due to the fact that we're taking off and landing on the same horizontal plane. The height of the ground isn't changing during our jump. If it was, then this statement of taking off and landing at the same speed, y velocity, would not be true. So the first thing we're going to do is find the time at the halfway point. So I'll explain what I mean here. If we have our jump, we have our initial takeoff point, we have our point 2 and our landing point 3. So point 2 here is the point of maximum vertical height in the jump. And this will be our halfway point in terms of time, and it'll be the time where the vertical velocity changes from positive to negative. So we can use that to our advantage here. We know that the actual y velocity at this exact point will equal 0 at point 2. So knowing that, we can use our equation v equals v naught plus at to find out the time of our halfway point here, which we can just multiply by 2 to get the time of the full jump. So this here will actually be v at point 2 equals to v at point 1 plus, sorry for that bracket there, plus at. And a is our acceleration due to gravity, and time is time. So we put our information in here. We know that our y velocity at the top point here is going to be 0. So 0 equals, and our takeoff velocity was 5.63. Yep. Plus negative 9.8 meters per second squared multiplied by our time. And this is our time at the halfway point. So we're actually not solving the total time. This is our halfway time, or when our y vel is equal to 0. So that means, our t 1/2 equals, that is 0.574 seconds. Cool. So some valuable information for this. This means our t total equals to 1.15 if you round it. And also now we can find what our vertical height is. As if you scroll up to the top of the question, we do need to find our height. We've now found the time of flight, so that is done. And we need the height and x distance still. So the x distance is easier to find, so why don't we just do that first, where our distance is just our velocity times time. We have our velocity, we have our time, so our distance x is, this would be 10.60 meters per second. As I said before, the x velocity doesn't change during the flight unless there's wind resistance, which we're not worrying about in this question. And our time is 1.15 seconds. Do the simple math, and that means our long jumper is traveling 12.18 meters. Pretty good jumper you have here. Our time of flight is 1.15 seconds, so now we just need to find our maximum height of the jumper. So, two equations you can use here. One that you may have seen more often is d equals v1t plus 1/2 of at squared. And if you do or don't know, there's also the equation v2t minus 1/2 at squared. Sorry, that took me a second to recall. So we can use either one, but if you look at here, our v2 is equal to 0, as that's our point here, as mentioned, where our y velocity is equal to 0. So that will get rid of this whole term, which makes it easier for us. If we don't get rid of that whole term, we're going to have a t term here and a t squared term here, which is going to make us use a quadratic formula. And personally, I don't want to use a quadratic formula. So we're going to go ahead using this equation here. So our d, I'm actually going to sub out with h because we're looking for the height here. And that's the number we're going to be solving for. So our v2t term, that's just all 0. And minus 1/2 of a is just our acceleration due to gravity. And our time, keep in mind this is our 1/2 time because we are looking for the maximum height, which occurs right in the middle. So at halfway of our jump. And that time we had was 0.574 seconds. So if we do that math there, our height is going to be 1.61 meters. So this is our maximum height right here, our distance in the x, and our total time of flight. Please message me. I'll put my email after the video if you have any questions. And if you have any other questions you'd like to be solved, please email me and I will try and get to them right away.